So look, a uniform rod of mass m and length L is lying at rest on a smooth horizontal surface. A particle of equal mass m moving with velocity v naught hits the rod perpendicularly at one end. This particle is going to hit this rod here, right, perpendicularly at one end, and sticks to it. It's going to be stuck to it. How long does the rod take to rotate through an angle of 90 degrees? So it's asking the time, how much time it will take to rotate by 90 degrees. Rod will take to rotate by 90 degrees. So look, after collision, what will happen? After collision, this particle is going to stick to this particle is going to stick to this rod, right? Both has the equal mass, so center of mass of the system will be somewhere here, right? So we can think about center of mass, right? You see, if you are going to take particle plus rod as system, you see there is F external 0, F external and torque external 0. So we can say P system and L system will be conserved. Okay, why do we need to conserve P system and L system? Because we need to find out time, we need angular speed of this rod, right? If we know the angular speed of this rod, angular speed is not about the body, not of a body, it is the whole body. Angular speed is of, it is defined by whole body. Linear, if we talk about linear speed and linear acceleration, then they are of a point. But when we are talking about angular acceleration or angular velocity, it's of the body, it's not of a point, right? So let's assume this body has the angular speed omega and vc, this is the velocity of center of mass. So first we can apply the P system will be conserved, right? So we can write mv naught plus rod is 0, so and finally 2 mvc. So from here we got vc as what, v naught over 2, right? Now what, we can go for L system conservation, right? So we can write, again we have to think about center mass. So this distance is L over 4, right? So initial momentum is, angular momentum is mv naught L over 4, and rod was at rest, and finally we can write the ICM and omega, right? We are talking about angular momentum, right? If you want, you can write individually for point or rod. Here I am going to write both systems together, right? So here we will get mv naught L by 4, and let's write the ICM. What is ICM? So rod ml square over 12 about its center of mass, but we are moving L by 4, so we need to 4 ml L by 4 md square, right? Parallel axis theorem. And for the point object we can write again ml square by 4, because this point object is, point particle is at L by 4 from the center of mass. Hello, yes ma'am. Okay मैम, नो प्रॉब्लम. जी मैम, सर कर दीजिए. जी जी, ओके. So we can write ICM here ml square, and you see here 1 over 12 plus 1 over 16 plus 1 over 16, that means we can write 2 over 16, right? So ml square, and this will be 1 over 12 plus 1 over 8, and we can go for 24, right? So it will be 2 and it will be 3 over 24 ml square, right? So 5 over 24, 5 over 24 ml square, and omega. So from here what we got omega s, mm cancel out, omega we got 6 v naught over 5l, right? Now the question is how much time it will take. So you see here we have only, it's a uniform motion, right? We don't have angular acceleration, so we can directly write theta equals omega t, right? And we need t, and theta is pi over 4 over omega. So pi over 4 and omega is 6 v naught 5l, right? So we can say it will be 5 pi l over 24 v, right? So we got this answer. Okay.